Okay, let's see what we got here. It's going to be a medium that I've done before. Alright, delete nodes from a linked list present in array. Linked nodes from linked list present in array. Begin array of integers nums and the head of a linked list. Return the head of the modified linked list after removing all nodes from the linked list that have the value that exists in nums. All nodes from the linked list that have the value that exists in nums. So let's see. So nums is the values to be deleted, which 1, 2, 3. So removing that, we get 4, 5. Move all 1s, you're left with the 2s. Move a 5, left with the same because there's no 5s. Alright, pretty simple. I think it's been a while since I've done a linked list or ones with nodes. Python's pretty easy with the syntax run, to be honest. Okay. So generally, because linked lists will you often have to worry about deleting the first node. Like this one, we want to have a, what's the term that I usually use? I generally have a header node. So I generally make a header node, which is a node that is going to store a link to the first node. And then I'll eventually return header.next. So header, what is the syntax here? Equals list node. And I want to make the value be whatever, -1, and the next be the head node. And eventually I'll return header.next. And that's just the basic structure of it. And now I want to iterate over nodes starting with the header. And it's kind of a process where you check the next node. What the next node is going to be, check the next node from the current node. If the next node has one of the values in nums, then you want to skip that. So you want to make the next node the current node, be the following node after that. So I think it's going to be while current.next exists, and also current.next exists as well. No, that's fine. I think if the current.next exists, then the current.next should exist because it's either going to be null or another node. Okay, so while current.next exists, if current node.next.value is in the nums list of values, current.next is going to equal whatever follows that. And then current becomes what's next. And return header.next. Might need to change the nums into a set to make it easier to check its existence in the list. I see. So skip too much. This is assuming this is assuming that the next is actually valid. So I think I want to make this into a while true loop. And maybe while this is true. No, while current.next exists and that next value is in nums, which is to be deleted, then skip over it. Skip, 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 and then eventually make this into the next. Guess while current doesn't equal null. Okay. Run will be the next step. Time limit exceeded. Oh boy. I see. So it went infinite on one of these things. So let's just skip, 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 skip. Current up next. Okay, or maybe it's too slow with the check if it's existence. Sure. Just the whole list, all 5004. Okay. Okay, maybe I'll make a remove is set based on nums. That in theory is faster. Yeah, okay. That was the difference. It was too slow looking for an item in that huge list. Okay. Yeah. Anything else here? Current header. Remove set. All current. So this basically breaks it. I could also do if statement here. Could be something like true and if current not equal to null, or if not current can break. Not sure if it's syntactically. While current. This is probably fine. Syntax looks a little weird with while current and then another while current up next. But besides looking weird, it still might be the most kind of concise way of dealing with this logic. While current up next value, and remove. Skip, 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 all the stuff that's removable. And then move the pointer to the next, or move the node to the next node. And check to see if that next node is actually still valid. Yeah, okay, I think that's good. Alright, summary. This is a few things for a few notes on linked lists and nodes, I guess. One is generally have a header pointer, header node, which points to the start of list. Create that at the start and use it. Create that at the start it's a dummy node where its next is the first node. It'll be used as starting current node. The reason to have it is because sometimes or often, because that is to handle deleting, removing the header of the first node. It'll make handling that case much easier. So in general, it's just like click this header node, and at the very end, return the next header node. At the end, return the next of the header node. Other points would be deleting nodes from a linked list is modifying the nodes that modifying the order / next linkage of nodes. So rather than having like 2 point to this one that's going to be deleted, it's going to be pointing to what follows 1, so it's going to point to the next 2 node. And that's done with this. Can be done using change the value of current node.next to be current node.next.next. So current node.next is this one. If current node is 2, current node next is this one. Current node.next.next is going to be this 2. So just reassign it. Reassign use a loop to skip the deleted nodes until one is not skipped. And then lastly, I think here since deleted values are given in an array, it's generally going to be O of n to look up, given big array. So convert array to set, so that lookup check if value should be deleted is faster. If you do a check of a value in a set string, it's supposed to be O of 1. Time complexity, this can be O of n, where n is the number of nodes in the array. Assuming conversion, actually also O of, let's say k, where k is length of, actually just the number of nodes in the linked list. Also k, where k is length of nums, the removed nums array. So basically this should be O of n plus O of k. to do the conversion of the array to a set should take as many elements, take as long as the length of the set, or length of the array. Space complexity should be O of k, where k is number of elements in num's array, as that will be converted to an equivalently